All right. Hey, good afternoon, NDC. Thank you for being here. I appreciate spending the afternoon with us here on day one. I think we're all lunched up. We probably got coffee, probably got tea, all good. I'm mostly a tea guy myself. So, yeah, I think we're ready to go finish off day one strong, unless you came for the workshops, but we still got tomorrow. I always love being a part of these NDC events because you get to have so many great talks, so many great conversations with people. And it starts to make me think about how long I've been working on the web and how long we've been effectively trying to solve the exact same problems. So for well over a decade now, we've been trying to figure out how can we best componentize our front ends. Does anyone remember Twitter's Bootstrap back in the day? Yeah, that was a really good attempt until the entire web looked like Bootstrap. Yeah, there's always been this holy grail of someone's going to build this one universal button, and this one universal button serves every need ever possible. We haven't quite gotten there yet, but this dilemma or issue is partly why I moved into the field of design systems. I come from a design background. I have a passion for accessibility, and I just really, really enjoy thinking in systems and thinking in patterns and conventions and standards. So most recently, I work at a company called OP, Osuuspankki. It is the largest bank and insurance provider in Finland, and I am leading their design system team there. Previously, I worked at Posti, the National Postal Service of Finland, and led their design system team there as well. So lots of large-scale projects, lots of work with the European Accessibility Act, but all the things that go into a design system, which are far more and far greater than just the component library. It feels like everything always boils down to the components at the end of the day, because that's what applications are primarily interacting with. So that's what we're looking at today, is how can we build components that are resilient to change? Something I'm probably going to say a few times today is that content will forever and always change. So we need to build our front ends in a way that accommodates and supports that change without breaking down and without introducing technical debt. And we're going to do that by first identifying what are those component patterns that tend to break down. I've stepped into a lot of existing code bases working on component libraries and design systems. I've worked with enough startups building these projects greenfield. I've come across a lot of component patterns that tend to break down as products evolve. We're going to learn what those patterns are. We're going to learn how cross-team collaboration can improve our components' lifecycle. And we're going to learn more resilient patterns for our components. How can we approach these in a way that allows our components to adapt, to grow, scale, evolve along with our products? We're going to do this by first looking at TypeScript interfaces. This is the main portion of the talk tonight because it's pretty agnostic, regardless of what framework or whatever you work on. If you're working on the front end, likely you're working with TypeScript in some capacity. So we're going to look at how do we manage our TypeScript interfaces. Then we're going to take a look at a React-specific pattern at the end. I will try to explain it in a way that isn't necessarily about the syntax of React, but the concepts. So maybe in Vue or Svelte or whatever framework you might be using, maybe there's a comparable alternative. At the end, we'll do a quick recap of key points. Slides will be available as well. Last bit of housekeeping. Does anyone know the TV show Psych? Thank you for saving me. Second hand. Thank you. Okay. This is my favorite TV show ever. It was on for 8 seasons, and inside of every episode of every season, they hid a pineapple. Now, back in the day when these episodes aired for the first time, you could find the pineapple, fill out a form online, and be registered to win a prize. Well, celebrating my love of Psych and mourning its recently-ish departure from Netflix, I hid a pineapple in their slides somewhere today. Looks exactly like this one, will be exactly this one, but it will be somewhere else in the slides. Be the first person to find it, scream, yell, get my attention, and you will also win a prize. Just don't politely raise your hand because I'm going to think you're asking a question And I can be like, oh, please save your question for later. And then it's super awkward. That's happened. That's happened. So housekeeping's out of the way. Let's get into our component interfaces. How do we make the most of our TypeScript interfaces for our components? And we're going to look at a few different sections here. First one, grouping similar props. It may feel pretty basic or pretty obvious what we're going to be looking at with some of these sections. But you don't really notice these things aren't there until you don't have them. And you start going down the path of really bloated, really complicated interfaces. Like we have here with the input. One other bit I want to note is unless I say otherwise, every piece of code that we look at today will have been taken from a live production code base. This stuff's real. These problems exist. They happen. We want to look at them and figure out how we can avoid making the same mistakes. So even this subset of an input components interface was taken from a live production code base. And we have a few different props here. A couple that sort of determine how the label should or should not be displayed. We have our different mode toggles, and we have a couple different sizes as well. But what tends to happen if you need to add a high contrast dark mode to this? Or what happens if you need to add an extra large size or an extra small size? You tend to add more booleans to the interfaces. I think booleans are just, they are a love-hate. They can enable a lot of great functionality, but they're so easy to use. They're so easy to turn to. They're the quickest way to bloat an interface. And this is an example of that. We have 5 props effectively doing 3 things. How do we want the label to render? In what mode or theme do we want to render the component? And at what size do we want to render the component? We want to group these individual components into categories, into characteristics of the component itself. And what this will allow you to do is if you're using these booleans and someone passes is large and is small, what should happen? You have to start writing defensive logic inside of your component, or you have to start writing conditional types in TypeScript, and that starts getting pretty complicated pretty quickly, right? So if we group these booleans into component categories, we're able to introduce the string literal union types and define available options for each component or for each category. So instead of having multiple props to handle the label and size, we just have single props for label type and size. Theme as well. If we were still using the Boolean conventions and we wanted to add an extra small size or a high contrast size, well, that's 2 more props on our interface. That's more defensive logic within our component. But if we group our similar props together, we can just add to these unions of string literals. And we can add a theme of high contrast. We can add a size of extra small. And we can introduce these new values, these new options, without introducing breaking changes. And this also removes the need to do those defensive checks because you can only set one size. Your applications start to type size. They get the autocomplete list from IntelliSense on which size to select, and they can only select one. You don't have to have those defensive checks within your component, that defensive logic. And we can extend this to the button as well. You know, different sizes, different shapes, different variants, whether it's going to be ghost, filled, outlined. I've worked on a few systems where this shape prop has saved my life a few times. Needing to get some things out pretty quickly to meet some deadlines, and being able to just pass in a shape of sharp because for some reason a button needed to be rectangular and not rounded at all. So by grouping these similar props together, we create a more clean interface, an easier interface to step into as a new developer, but also a more reliable, stable interface as the maintainers. Again, we don't have to check if it's ghost and if it's outlined because you can only pass in one variant. So this makes it easier for us to add new features as content changes. Makes it easier for new joiners to onboard into the components themselves. And it makes it easier as the maintainers to manage and edit and maintain this component. How I like to think about it is with boy bands. New Kids on the Block happened. They were amazing, so much so, out came Take That and Westlife. Right? It started small. It started as a self-contained thing, New Kids on the Block, and then we got a couple more. It grew, it blossomed, it flourished, and then it exploded with the Backstreet Boys, NSYNC, 98 Degrees, LFO. Oh, we also had O-Town in there. And a whole lot more that it was quite tough to find gifts for. There's a level to it, I guess. But we still had then One Direction, BTS taking over the world. An example of how something can start small and self-contained, you think it's quite isolated, and then in come different properties, different needs, different platforms, different projects, different themes, and quickly your components can become quite unwieldy in a pretty wide network of options, variants, and considerations. So whenever you're building components, just ask yourself, what would New Kids on the Block do? And it'll steer you in the right direction. It's led me correctly my whole life, so I can vouch for that advice. Another way that we can group component props is through this model of having a Boolean toggle that turns something on and then shows the data that's behind it. We see this a lot with error messages, like we have here with this input where we have the has error Boolean, and then we have the error message string. I really couldn't find a good term for this. So I was just thinking of it as like a data gate model. We have the data of error message, but it's locked behind the gate of has error. We see this with things like icons, has icon and icon, has tooltip, tooltip, has help text, help text. We're effectively doing two props or using two props to do one thing. And again, in React world, we would do something like this. This is an example of some JSX I just threw together for this snippet. But if you've written React, you've probably written something like this where you check to see if has error is true, render the error message. But you probably also want to check in here, does error message even exist? And now you're doing two truthy checks to render one thing. So we just want to simplify and just remove that gate prop and just have error message or just have icon or tooltip and assume and trust that if you pass an error message into the component, you're probably going to want to render it in its error state. You're going to want to toggle aria invalid. You're going to want to show the error message, maybe handle some focus management within your forms, all predicated off just one error message prop. Now, there might be some edge cases here where you maybe need to handle like a null type error specifically, in which case you may still need that gate prop. But unless you're specifically covering for like null use cases and edge cases, you can generally get away with just having one single prop do that one thing and not have two props doing the same thing, sharing the same responsibility. The next key I want to look at is, normally I say this is my favorite one. Like I said, I love thinking in systems and patterns, but this is all stuff I work with every day. All of like this whole talk is like my favorite kind of stuff. I love thinking about it, love talking about it. I'm pretty sure my wife could build a component library at this point with just the amount of time I've spent talking to her about it. But consistency is key. Probably like 1A favorite thing in this talk. Because if you know how to use one component in your system, you should reliably know how to use the others. If you know how to use the button, you should intuitively understand how to use the icon button, the input, the switch, the icon, anything else in your system. And this is done by creating consistent conventions throughout the entire code base. So if you know how to use one component, you should know how to use the others. We're going to take a look at the button and the switch to compare these two things. Now, not only are these two subsets of live production code, these two interfaces are subsets of live production code from the exact same code base. This happens. Each component has a disabled state, a busy state, and it handles sizing, but it handles all three characteristics differently. This is really common to find. Developers, we like to change jobs a lot. It's kind of our thing. So maybe I built the button, and then I left, a new developer came in, and they built the switch their way. Maybe I didn't document the conventions, and they just did it however they felt best. Maybe I did document the conventions, but the new dev didn't give a shit, built it their way anyway. That happens. Maybe you're managing a distributed design system where there's no central ownership. There's no real governance. It's just different teams contributing different things into the same repo and calling it a system. Very common to have this happen. So now, if I use these components, I have to learn how the button works, and I have to learn how the switch works. And if your system has 40, 50, 60, 70 components in it, imagine the cognitive load of trying to understand and learn how every single component in that system works. So instead, we want to make sure that we follow one single set of conventions that governs the entire system. Previously at Posty and most recently at OP, we call this our terminology system. We define what all the shared props can be across the system, what those shared values can be, and what the shared default is. And then if we ever need to turn to a prop for size or is busy or is disabled, doesn't matter what the component is, we have the convention defined. So as our system scales, the conventions remain the same. So here we have is busy, is disabled, and we have sizes defined with the 2-letter t-shirt values. We've also introduced the icon component to show that these conventions, it doesn't matter if it's an interactive control or a static piece of media, the same conventions apply. Like I said, this also applies to not just the props themselves, not just the potential values, but the defaults as well. And this is one of the more challenging things when stepping into a new team, is aligning these defaults in a conventional way. So anytime in our system, if you have a component with the prop of size, our rule is it must default to medium. If we have a prop of variant, it must default to filled. I don't care if it's an input or a button or an icon button or anything else, its size will always be medium and its variant will always be filled. So we define this as a top-level set of terminology that governs the whole system, and we have to work on this between design and development. And when you put these conventions in place, define this set of terminology that governs the whole system, you're no longer learning the individual components. You no longer have to know how the button has a size of small or defaults to small and the icon button defaults to medium, right? You don't have to learn each individual component then. Because instead you're learning the conventions that govern the system. So you define these conventions, obviously you document them and share them. And then you have one set of conventions that manages and governs the entirety of your system. It doesn't matter if it's 20 components, 100 components, how many different brands and themes and modes and platforms you have to take into consideration. That one set of conventions will govern your whole system. Now, for the record, this is code I made up just to serve this narrative, but I'm pretty sure I've written something like this in Storybook at some point. Because we just have a small button next to a small input, medium button next to a medium input, large button next to a large input. And this is to illustrate that collaboration that has to happen across teams. Because not only should your code be consistent, so you have a button with size medium and an input with size medium, they both default to size medium, But if you're using these components that have similar props and values used, it should also create consistency within the UI itself. So you have to collaborate. You have to make sure that you're aligned between design, between web, between mobile, that there is consistency within the system. We have to have reliability and trust within the system. And this is one of the harder things to sort of get through. I've been in a lot of situations and a lot of teams where, yes, they're the design system team, but design sort of works over here. And then once they do some things, they send a link to a Figma frame, and web comes over here and they do it. And it's two independent, isolated products that they're calling a system. And then someone like me shows up and I say, hey, you have to collaborate, have some meetings together, kick things off, align on patterns and conventions and terminology. And there's usually a lot of friction at the start of that. But once you get that friction resolved, you get that first release out and you kind of see how that collaboration creates consistency for not just the design system team itself, but the applications using your system. Then you start to see the proverbial fruit of that labor. In that case, we have nice UI consistency between our different sizes of interactive controls. So if we imagine a really long form that might have a select menu, it might have the different submit and clear buttons, it might have a text field, text area, might have all these different form fields. But if you render all of them using the same consistency within the props and the values, that they're all going to be size medium or size large, they're all going to be variant field, you're going to have a UI that reflects the consistency from the code into the UI as well. That does take collaboration, that does take work. It is pulling teeth sometimes, but it's well worth it. Much like wisdom teeth, I've been told. I still have mine. The last part that I want to look at for TypeScript interface management is do not reinvent HTML. Spoiler, I love this one as well. I generally believe that if you're working on the front end, you should have an understanding of HTML. You should have a pretty strong understanding of HTML. It's a lot more in-depth, nuanced, and capable than I think a lot of people give it credit for. And that's because it's been in development for 50 years, 60 years. I don't know time anymore. And a lot of people, a lot smarter than myself, have worked on this, developed HTML, developed its conventions. And if we're building a system that leverages these HTML conventions, and we're building it for people who write and know and understand HTML, every time we deviate from an HTML convention, that creates another piece of friction, another new thing that our application teams have to learn. HTML exists for a reason, its patterns exist for a reason. A lot of them are legacy related, but they're well-intentioned. So every time that we're creating components like a button or an input, these components that are abstractions of native HTML elements, we want to make sure we're following standard HTML conventions, because every time we deviate from that, someone comes in and says, I know how to use a button, but I don't know how to use your button. We're going to look at the input to demonstrate this. Again, I worked at quite a few different startups where we were doing some brand new things, and maybe you get a design for an input field, and you just have to handle a login form, maybe it's at the start. And the designer hands you this file where it's like, okay, you have a pretty basic, straightforward input with a couple different states and error messaging and all that stuff. So you go to your interface and you type everything out and you say, all right, cool. We did it. We made it. We're here. Right. But like I said, content will forever and always change. And our input does as well. And now we have some different considerations we need to make. We have different use cases to support different forms to build. So now we have some kind of leading and trailing accessories. We got different types defined. We got some lengths defined as well. Our input went from this to this pretty quickly. And now you're thinking, okay, calm down, we'll get there, and we get there. Whoa, I think you had it first. I never know where it is, so it's a surprise to me. Give him a round of applause. You can come up and collect your. Thank you. He wins chocolate from Finland. All right, I forgot that was there. Okay. Reset. Inputs. Started with this. Now we're here. Yes. So we notice our interface starts getting pretty complicated now. We got a whole bunch of properties in here for error messages and names and placeholders and types and descriptions. And some of these are HTML attributes. Some of them are custom props to the component itself. It's getting a little messy. And then it becomes this. Good time to remind you that every code sample, unless I say otherwise, has been taken from a live production code base. Even this. I know. But we get here for a pretty straightforward reason. It's because we deviated from how HTML natively works. We want to make sure we handle HTML attributes separately from component props. They serve two different purposes. HTML attributes you can inherit and extend. They are defined for you. They have behavior for you. They will update whether you want them to or not, just as the spec changes and evolves. But then you have your own component props. These are properties specific to your beautiful little component. Customizes the behavior, the visual style, the characteristics. Props specific to your component are separate from HTML attributes that generally apply across the board. And because we didn't separate these two things, here we get this. We get a mess of an interface that is impossible to maintain, impossible to learn. And this is when teams will tell me it's easier to build it myself than to use the input from the system. I don't blame you. I wouldn't use this either. So we want to make sure when we're building components that are abstractions of native HTML elements, we follow those HTML conventions and standards, and we treat those attributes separately from our own individual component properties. And in TypeScript, we can handle this by using the extends in the React world. And can someone confirm who maybe does Vue or Svelte? Do you have access to these kind of types in those frameworks as well to extend? Yes, thank you. Yeah, so you can extend these types from your framework with TypeScript. And now our component has access to all of the native HTML input attributes, which means our interface now becomes this. We extend the HTML because we're handling those attributes separately. And now our interface is only the property specific to our input, our description, our error message, our input size, which I would change that now. I would call that HTML size, perhaps. But nevertheless, you can have slots, accessories, however you want to call it. Again, it doesn't matter what you call these things or what the convention is, so long as there is a convention. But now we have properties specific to our component on our interface because we just extend the native HTML ones and inherit those attributes. So when we extend that, we get a much cleaner interface, much easier to learn and maintain. Now, one of the most common deviations from HTML that I find over and over all throughout my career, I have found button components with a text prop. Maybe you call it title. Maybe you call it label. Again, names don't really matter. But effectively, we're creating a single string property for this button to render, which makes sense, right? If you just scope the button to support a single string, then you can style it with CSS easily. You can reliably ensure they're just using the correct tokens, the correct spacing, the correct sizing. No one can really overwrite this and break your component, except design, who can overwrite and break your component by saying, hey, our new loading state wants to have italicized text, and we want to have a nice little like dot animation. This is where that cross-team collaboration comes into play, because maybe you're in an environment to where you can push back and say, hey, sorry, can we approach this a little bit differently? Can we drop the italics? Can we maybe change it up a little bit? Maybe you're not in an environment where you're able to push back like that. I mean, there's a lot of remote segregated teams. Sometimes it's hard to communicate, but you want to have that collaboration. But in this case, we're going to say we don't have that collaboration. So now what do? Our button no longer really supports the use case of what we've built it for. So maybe we get a request, a support request that says button now needs to have support for a loading text. So now we at the design system level have to think, do we add a loading text prop to this? And how, if we add that loading text prop to this, how does that affect the other components with loading states in the system? Do they also need loading text props as well? Maybe we say, all right, this wasn't the right approach. Maybe we create button v2. We release that, and now we have a lot of technical debt in the code base. Now we have this separation. Maybe the application just grabs our tokens, recreates the button themselves so it looks like our button, but it isn't our button. And now whenever we make a change, it doesn't reflect in the application, and it gets messy really quick. All because we deviated from HTML, which makes me ask the question, and I need crowd participation for this. Answer me this. In the context of an HTML button element, what is a button? You can just shout it out. What is a button? Form submit. Okay, form submit. Anything else? Again, please. Interaction. Yep. What do you have? Beautiful. Okay. This was not scripted, but a button is semantic, interactive container. HTML doesn't care what you put in that. So much so, you can put another button inside of it and shoot yourself in the foot. That's the beauty of HTML. But a button is nothing more than a semantic, interactive container. So when we break that convention and just scope it to use only a text prop, well, now we've broken that convention. We've broken that container convention of a button, and now you have to learn how my button works over your button. And it just creates one more cognitive step of onboarding, of maintaining, all that stuff, because we deviated from what a button actually is. A semantic, interactive container. So when we update our button and we treat it like the native HTML button that you could put anything you want inside of it for better or for worse, now we have the ability to just swap in and out children based on the state of this button. This is also generally pseudocode for the is sending and the M and all that stuff. So we've updated our button to follow HTML conventions, and when we do that, we've now created greater flexibility within the component itself to adapt to ever-changing design and content. We can always rely and trust on our CSS. If you fear that something is going to go inside of this button that maybe breaks conventions, well, leverage CSS more heavily. Leverage greater collaboration with design principles and best practices and standards to make sure that we're not putting anything objectionable into this button. But if we're making components that are abstractions of native HTML elements, we want to follow those same HTML conventions and patterns. They've been around forever. If you're working on the front end, you probably know them. And we can follow those, leverage that shared knowledge, and minimize that learning curve into our system. Now, for very, very astute observers, there was one other issue with the input field, and this is probably the second most common issue I find with systems. We have an onChange handler on our input here, And we're just going to update this callback to pass the value of the event. Now, I've seen this in a bunch of code bases. 7 times out of 10, whenever you have an onChange handler in your input, you probably just want the value. So great. You build that into your component, you give the value, and everyone's happy until they're not, because somebody needs access to the event itself. Someone needs access to the class list, maybe the sibling, maybe a parent element. Someone needs access to something other than just the value on this callback. And we find ourselves in that position again. Do we create a breaking change in our component and have to somehow migrate that change throughout the entire code base, which is probably going to be tough unless you're in one massive monorepo throughout the whole organization? Maybe we create input v2, ship it, and have a separation and discrepancy in the code. Maybe the application team has a deadline. They take our tokens, copy the component down, and now we have something that visually looks like ours, but isn't ours. All because we tried to be clever and give you what we think you need all the time. You will need value a lot, but when you don't need it and you need something else, it's going to be much easier to have access to the full event, which is what the native HTML attributes give you. You don't want to overwrite or deviate from these standard conventions, these standard events, these standard callbacks. If the standard callback is giving you access to that whole event object, we want to make sure our component also provides that full event object. And the people who maybe can't be bothered to write event.target.value, we have AI for that now, right? But for the 3 people out of 10 who need something else, they will use this, they will love it, and you will not get any more support tickets about this. So we have grouping similar props, we have consistency as key, and we have don't reinvent HTML. 3 patterns that we can follow that if you put these in place into your code base, you could pretty much say goodbye to really bloated, overcomplicated interfaces, because they always end up happening. You can say goodbye to those, or I guess if we're staying on brand, you can say bye to them. Which brings us to our last part here, which is a little bit of component pattern specific to React. Again, I'll try to talk about this in a way that maybe conceptually might still relate to other frameworks, because the syntax itself isn't that important, but the concept is. The concept being, how can we make sure that a single component can stay in sync across different files, different parts in the UI? We see this a lot with things maybe like popover menus, dialogues, perhaps accordions, maybe tooltips, things that in application development, you might have a header file that has a button that opens up the popover menu, but the popover menu has a whole lot of logic for permissions and what is actually active and visible based on your user rights and all that stuff. So your popover menu might be in a whole other component file. And now you're kind of trying to manage the state of one component across multiple files, across multiple parts of your UI. And we can look at creating a single component store to manage this. So like I said, we're going to take a look at the popover menu. Might open on different sides. Very, very stripped down version of a little menu here. But you can imagine clicking the little hamburger icon button and the popover menu opens to one side or the other. So we're going to start by creating this single component store. We're going to take a look at some pseudocode here of what this store might look like, what it might do. But generally, we're going to create one centralized store that manages the state and behavior and logic of this component. And we're just going to pass this store throughout our code base to wherever the component itself might be, and wherever its trigger element might be, or whatever its associated element might be. So in this case, we're going to create a store by using the use popover menu hook. That hook will return us a store object, and we pass that store object into our icon button and into our popover menu. So these 2 components at different parts of our code base will be referencing and sharing from the same centralized store. So in React world, we would create a hook, a use popover menu. And here we tend to handle the open and closed state, the is visible or is not visible state of the menu. We will probably manage keyboard focus navigation. Probably even manage ARIA IDs so that you can put an ARIA controls on the trigger element, maybe have an ARIA described by, and reference those IDs, and you can keep all those IDs internal into your popover menu hook itself. So then whenever you expose a store, that store has access to the methods to open and close the popover menu. It has access to the different IDs for the ARIA associations. And you keep it all centralized in a single store object that you can pass from one component, one page, one file to another, keeping a single component in sync across different places. So if we build out our hook a little bit here, we can see we have some basic menu is open state values. We have the ref created for the trigger element itself. And then in this hook as well, you could even go through the ref, the trigger ref, and make sure that it's an interactive element. You can check to see, is it a button, for example? If not, you can maybe manually append a roll of button and a tab index of 1 on it. You can handle a lot of your accessibility considerations behind the scenes within this hook. Because that way, at the application level, they don't really have to worry about it. I haven't worked with many front-end devs who are going to think about ARIA associations between buttons and menus. As the accessibility guy who works in design systems, that's usually fallen onto my table. So by using this centralized store model, we're able to kind of hide a lot of that logic of keyboard navigation, of ARIA associations, of positioning of the menu. We can hide a lot of that behind the scenes in this hook, but then the application, they will instantiate that hook, and they'll get that object returned back to them that has access to things like open and close, the different refs, and all the other IDs we may have associated. And then we have our one component icon button that might live in a header file, a header.tsx file or something. And our on click here will point to that store's set of actions. So we're not managing the state of the popover menu outside. We're pulling the reference to the hook values from set menu is open. We're returning those as the open and close methods. And now our icon button is just referencing those methods from the store itself. So whenever this on-click triggers, it's going to update that state value in that store in the hook. And then whenever we pass that store into the popover menu itself, these two things are now in sync because they're sharing that one central reference. So we create a single store that handles like the open and close state. Our icon button will update that state, and then that same shared store will go into the popover menu, render that out as well. There's a component library called ARIA Kit. I saw them. That's where I really learned this from a few years ago. Definitely have expanded upon it a bit more, but it's still a pattern that I turn to a lot because there will be lots of instances for applications where they might just need a really simple use case for the popover menu. They might just need to render the popover menu itself, pass in the placement, pass in the callbacks, and be fine. But there are going to be instances where applications have some different constraints, some different limitations, and they're going to have a trigger element in one file, they're going to have a popover menu in another file, and they need a way to keep this consistent and clean without having really large providers and lots of re-renders in their code. So we can, again, move a lot of this logic into a centralized store, share this, and now applications can use this as an escape hatch for complicated use cases. But these component stores don't just manage like the open and close states. You can use these as the entry point into your components themselves. You can think of these hooks, these entry points, as the interface that we were just looking at, where it can be expanded to handle your own on-close, on-open callbacks if you want to pass anything like that. You can pass in your placement value, so you can position where that menu is going to appear relative to its trigger. And we can handle all of this logic inside of the popover menu itself, or inside of the popover menu hook itself. So it allows us to keep components in sync across different files and keep different components associated. Because what I see a lot of times is in this specific use case, we'll have like a popover menu trigger component. And that component always tends to break down because eventually you're going to need maybe something that's not an icon button to trigger the popover menu. Sometimes you might need an actual like link or something. Sometimes you need an icon button with a different icon and you don't provide the ability to customize that. Maybe you want to use it as a tooltip trigger, right? There's a lot of use cases here to where just having a single popover menu trigger component just tends to create more limitation. So by instead creating this hook, it doesn't matter what your trigger element is. You can just pass in our own values from the hook by using that centralized store and keep everything in sync between the menu and whatever trigger you want to use. So, like I said, we're going to do a quick recap here of some of the key points. We have the interface management with grouping similar props, treating props as categories and characteristics. We have consistency as key, defining one set of terminology and conventions to govern the whole system as it scales. We have don't reinvent HTML, leverage it, use it as something that we should all know already, minimize that learning curve of your system, and then component stores. There's lots more things that we could get into, but these are some of the main ones I wanted to highlight today. And I want to leave you with one last key point here. We spend a lot of time thinking about buttons and looking at code and thinking about inputs and trying to manage this code level stuff. But in the context of like organizations and application teams and design systems, you're not really just building components. Components are sort of just the middleman. You're in the process of building trust. Application teams have to trust that what you're providing will solve and build the things they need to solve and build. They need to trust if they grab for a button and that button in Figma is using this property and this property, that those properties exist on the code side, and putting those things together will create a unified UI. There has to be trust there. There has to be trust that if someone does report a bug, it makes it into the code and you've built a system that is resilient to these requests and these changes, and you can accommodate these changes without having someone do a really heavy major version refactor. So it's simple to focus on just the components themselves, but we're building trust throughout teams, throughout organizations. And if there's that trust, with that comes respect, and with that comes greater feedback and ability to use, consume, and update and grow a system. And there's always a disclaimer. It depends. I've said it a few times today. It doesn't matter what your convention is. Names don't matter so long as you have a convention, so long as you have a set form of names that you use. As long as people can trust that if you have something with a size of medium, everything will have a size of medium. So find the conventions that work for you. Find the language that works for your teams. And the conventions depend, so long as the conventions are there. That's the biggest thing. Thank you very much.